Hi. So I will talk about control loop. And implemented logic on the DCS on the control system. So we will take an example of an equipment which is control valve. So let's take an example of this control valve here. So this is a LPBP PCV. That means low pressure bypass pressure control valve. So the logic of this valve is here. This one. So this is the behind of the control valve action. So this is the PID, or the proportional integral derivative block. Now what I'm going to emphasize here is the comparison between this implemented logic in the DCS and the control loop. So what is the difference? Basically the logic is the same, but only the drawing. This one is using the Sama symbol or the sketch for Sama symbols, and this one is a function block. This is now the actual logic. So this one is being sketched by the control engineer designer, and this one is being implemented by the control system integrator engineer. Now the basis of this control logic is the Sama, because this is the first logic during the design. So this one during the integration. So let's take a view the comparison. Now this is the PID block. So we can also view the PID symbol in here. This one. This one. PID symbol in here. So this symbol is the difference. There is minus and plus. There are two inputs, and here is the PI. Actually this is a proportional integral only. Here proportional integral and derivative. But if we try to open the inside of the configuration of the PID parameters, we can see in it here. Now the algorithm you can see there is integral time, derivative time, and the gain. The gain is the proportional. Now the integral time is 0.2. Forget this, disregard this 1/440 because this is the high limit. But the working time is the 0.2. This one. This is for integral time. Now for derivative time, the T2 is 0. That means it has no use. So this black, even though this is a PID, but used only for proportional and integral. Now the overall gain is 1. Okay. Now here, this line here is the coming from the process variable, from signal coming from the pressure transmitter on the process line. On the other line is the set point. Usually the set point is a fixed value. It's a fixed value, but in this example, in this particular control, the set point is not a fix, but rather a value coming from another pressure transmitter and from the another line. Okay, this line and this line is not the same. They are different, but interrelated. Okay, interrelated. Now we can say that the set point is cascaded from the other line. Cascaded. Okay, so from here the actual value of this transmitter is first passed through the function block. It is fx function, or what we call it, x function. The output of this function, the output of this is a function of this input, of the input. Okay, let's take see if it has the same in here. Now if set point is here, the coming from the actual pressure transmitter. Okay, and the set point is here. This one coming from the actual pressure transmitter. This is the actual pressure transmitter, that one. And also before that, after that one, it will pass through function fx. So this is now the function. So there is a formula, but we cannot see the formula in here, only figure. This one, this is the x and y function. Sorry, it's a blurred. So this one, the x refer to the input, the y refer to the output. Now 0, if 0 input, output is 11. You can see. No, sorry, my hands is shaking. No. Yeah, 0, 11, 24, 11, 33, 14. So we can see it here. We just double click this one. Now 0, the x 0, the output is 11 in every 24. This is pressure input. This is the pressure. In every 24 pressure, the output would be 11, 33, 14, 41, 16, 15, 19, and so on and so forth up to here. The 130 maximum pressure in here, the output would be 39. Now let's see the actual. The output is the input is 121.5 something. This is the pressure coming read out coming from this transmitter. Now the output is 39. So let's verify on the block. The input is 120. The input is 129.5. Is in between with this one. 121 between 130. Now what would be the output? The output is in between also 39. So that's it. 39. Whatever the value in between in here, because the 130 also 39. So that means even the maximum from 121 up to 130, the output would be all 29. So that's it. You can see the output is 29. See, there is a formula in here, but the process engineer did not show it, only the function. Okay, the x and y coordinates. Okay, what I'm going to emphasize is a comparison between this one and this control loop using SAMA. Okay, but let's discuss a little for how the process being going through. Okay, the set point is first pass through a ramping rate. There is a ramping rate. The ramping rate, which is being determined by this 0.6 ramping rate. It is 0.6 per minute. So whatever the value in here, it would the output would not automatically, let's say this is 39. So 39 will be achieved through this ramping rate 0.6 per minute. Okay, so ramping, we can see it in here also. Every block in here we can see it in here, another symbol. Now ramping, we can say it velocity limiter, because it is 0.6 per minute. So that means a rate. This is velocity. So we can see it here, velocity limiter, this one. V, upper velocity, greater than velocity limiter. So here the value here is 1 per minute, but it is changed in the actual by 0.6. Okay, this block here is being omitted. That's why it has enclosed by a cloud. It's being omitted. This one also being omitted, so you cannot see a line here. You cannot see a line here. This line is not part of the logic. This is a part of the frame. Okay, and another block. This is a transfer switch. Okay, we can see it here. This is what here we can it is not transfer switch, but a logic or G selector. It's just the same. So here another first transfer switch. There are three line inputs. So the output would select coming from this one input number 1 and input number 2, the 39, and this is fixed value 4. This one G, that means will determine which particular input will become the output. Now as of the moment, this red color denote that it is in logic 0 condition. Now if it will become a logic 1, this fixed value of 4 will become the output, and consequently it will become the set point. Okay, but right now it is a red signal, that means 0 logic, so the input is 39. So the output is selected coming from the input number 1, which is 39 in value, and the set point also 39. Okay, now we can also see it here, because as I've said, every block we can see, we can reflect it is reflected from this control loop. Okay, this is the transfer switch or the G selector. Now the fixed value of 4 is here. The 39 value is coming from this line. This is the actual value. So to determine which particular input will become the output is this. We can see the broken line. That means it is in logic signal 0 and 1. So if logic 1, the fixed value of 4 will become the output. If logic 0, the process value will become the output, and consequently become the set point. Now also to determine when will be this line become logic 1, so the decision making will be in here condition. This is R, meaning set reset logic block. So we can see also in here. Now this one G. Okay, track. We will track the G line. So there is RS A. So reset and set, A is a number. So this is the first block of RS. That's why A. We can say it RS number 1 or RS number 2 if there's another RS in here. But here it is denoted A. That means it is a first RS block. Okay. So if RS, that the same as flip-flop in electronics logic. So flip-flop. So there is a set for set condition and the reset condition in here. For the set condition, it will determine by this condition. We can see it boiler firing. So that means this green here is logic 1. That means if there is a boiler firing, it will become logic 1 in here, and on the time delay with 3 seconds time delay, it will goes out logic 1 in here for pulse. This is a pulse block, meaning one shot pulse coming here. This is momentary signal. So logic 1 in here momentary, and after 3 seconds it will be gone. Okay, so after that, if the set condition is logic 1, so the output would be also logic 1. But the moment to reset or to off state this set reset logic, this condition will be satisfied. GT25, that means the actual position of the valve greater than 25%, it will become logic 1 in here, and another pulse shut off, one shot pulse in here will be the reset signal. So if that's happened, considering this is logic 1, if that's reset condition will be complied, then it will become logic 0. So logic 0, so the 39 will become the set point. So okay, so what I'm going to emphasize is a comparison of this implemented logic in the DCS or in the control system between the control lock using SAMA symbols. This is SAMA symbols. SAMA. You can SAMA. Here, you can research the meaning of this one. This is scientific apparatus. Okay, you can find it, the MA. Once again, this is the logic of control valve, low pressure bypass control valve. This is the bypass control valve of the low pressure turbine blade. Okay, once again, I am Flory. Thank you.